Welcome back to Castlevania Symphony of the Night decompilation on Made Up of Wires. That's just what we're doing. You can go to soten.z.dev to learn more. And we are working on what I think is the spinning coffins in the Grant Ralph Sifa boss fight. I'm not 100% sure. I don't have a checkpoint there yet. Working on it, but we'll get there eventually, and until then we can keep working on those functions. So we're going to use decomp.me, continue on where we were. If you have questions, feel free to comment, like, subscribe, and let's get going. So we're going to go back to decomp.me. We have these scratches already from yesterday. They're a good portion of the way down, about 80%, 70% on the PSP. So I'm flipping back and forth between the PSP version and the PlayStation version. They both have their advantages. The MIPS to C decompiler that we use, M2C, I feel like in general does a better job with the GCC output from the PlayStation. On the other hand, the PSP version was compiled without optimization, so the MIPS assembly is easier to read and easier to follow. And so we can use both of these things, two equations, many unknowns, and we can get to some solution. So let's keep going and do that. There's some interesting things that I see here. So at the top, kind of the preamble to any function, especially functions that use variables, you'll see a bunch of stuff get pushed to the stack. And then at the end of the function, usually all that stuff is coming back off the stack.
Sorry, I'm having problems completing your request. Please try again later.
Into registers.
If you have issues, please contact support.
And in the original, we actually, right now for the PlayStation version, we have a much larger stack, much higher stack usage, which typically means more variables being used, more things that need to keep data live at any time than we do in our version. If we look at the PSP version, however, which is typically more sensitive to that, those line up almost exactly right now. And so I'm going to go with I'm going to trust that the PSP version is correct, and that there's something else we'll find along the way that'll help increase the stack usage. Usually we don't want to do that, but in this case we do. Hey Dizik, good to have you back. Today's going to be a short stream. We'll finish this one up hopefully quickly and then get going. So I know that there's stuff that is done already. The main things that need to be worked on are this debug test case, which is going to eventually be just an import, but we could pull that imported code in, and that'll help clear up some of the stuff here and just get rid of that noise. And then this ending section is where most of the work needs to be done. So let's do the import first, and then oh, why is my button not, oh, give me 1 second. There we go. I switched scenes, and maybe I should have done this the opposite way. I wanted to I have just a bunch of cruft in my current OBS scene from over the years. Basically, anytime I add a new layer, I just leave it in there disabled, and I wanted to get rid of that to make it a little easier to switch between things. And every time I restart OBS, I need to tell it which USB devices to use. And anyway, not your problem, my problem. But when I switch that over, my external buttons are still pointed to the old scene, so they weren't working. All right, so we're gonna look at source st pad 2 anim debug. That is where that last switch case is going to come from. And that will just slot right in and should basically clean up anything between 100 and 123. And button symbol, oh, I missed that definition. Get that here too. And there's going to be things like this. I'm not going to worry about them. Buttons are different between the PlayStation and the PSP. They're different constants, and we just don't have to worry about that. Oh, that's interesting. I should, maybe I should do that. I don't know a good way to do that. Dizek said, the transition between the terminal and the browser were nicer when I switched between those instead of just hiding or showing the layer. I'll think about that. If scenes can be nested as sources, I'd be more inclined to do that because there's about a dozen things. I mean, it's nothing fancy, and there's still like a dozen things that you need in a scene. All right, so let's get going down here. The first thing is we have a bunch of. It looks like maybe flags getting set up into various variables. Oh, these are all scratch pad addresses. So it looks like we're creating 3 variables with pointers to different areas of the scratch pad. So let's go look at that. It's out of order on the PSP. It was out of order actually on the PlayStation 2. I think that's an M2C-ism, not something that the compiler did, because in the compiler output we see this at the end, as expected. And so based on these, this is gonna suck having to re-scroll this each time. So we're loading in the upper 16 bits, the bottom 1, which is basically the start of the scratch pad on the PSP, and then a 16 in the lower. So we're looking for 10010 in hex, and then 10008 and 10028. And so that's how it will show up. And we see those. Here's the 8, here's the 28, and here's the 01. So we have all of these things. So it looks like 001 is going to be a matrix pointer. So I'm going to call that SP matrix. Let me see what the GT rot matrix signature is. Oh, isn't that what it is? Let's look up rot matrix. That actually only has one parameter. No, it has 2. Oh, interesting. So it's 2 on the PSP, but only 1, and that's why they're different functions. So the args are a S vector and a matrix. I wish this was a more modern version of C where I could just declare these variables here, but I can't, fortunately. So I'm going to call this spad matrix, and we'll call it, maybe I'll just call it SP matrix. And we'll have an S vector, SP vector. And what else? I think we need one more matrix. Ugh. Nope. What is... matrix here, vector here. Where is 0010? Trans matrix. That is also a matrix. So the transformation matrix is separate. So we have, call this rot matrix then. And then we'll have I'll throw those up there, and probably those will be used elsewhere, but we'll see. So we're going to go down here. We have the trans matrix first. And this is going to be maybe SP4. Let's actually call it SPAD 4. So it's happening inside. And do I have the... Yes, I do. Then we have rot matrix. And that's correct, it looks like. And then we have S. What I didn't call it S vector, did I? And that one was at 28, so it's 6 words in. Okay, and so now, oh no, more than that, 10 words in. Okay. So now we've introduced some additional variables on the stack. Actually, we might have too many variables already. I didn't even think about that. So instead of getting registers, each of these is getting pushed to the stack. And then every time we use them, they're going to have to be reloaded, which is a problem. But we'll deal with that when we have to. So now we're going to use these variables instead of using pointers directly, which should make that a little nicer. So we have our SP vector, and that'll have... I can't remember if it's VX, VY, VZ. Yeah. Go back over here and check our work. This is going to be a bit of a mess, though, if we're pulling from... oh, this did get put into a register now, which is good. We're slightly off. This 0 is not correct. This one should be easy. Okay, so we have all those. Now we're going to pass that vector where we have 28. Basically, anywhere that there's a 10 here, it's going to be transformation matrix. And I wish I remembered any of my matrix math to interpret this better, but I do remember enough to be dangerous. Oh, it looks like it's a vector and not an S vector. We'll have to... no, it must be an S vector. That worries me. Because these offsets are going to be wrong. So... which part is wrong? See if we have a function signature somewhere for transformation matrix. We do. So the current function signature wants a vector here. But everything suggests that this is an S vector. So I'm going to cheat for now, and I'm going to cast it as a regular vector pointer. That would be very bad. I'll make a note. So it's either something wrong with what I'm doing here, or it's a bug in the code, and that could be. Now let's get back to fixing the matrices. Oh, and maybe this is my fault. Maybe I read this wrong. Probably. This probably should be the rotation matrix. Which takes an S. Maybe that's where the S vector came from. And what we're setting. So I did this wrong. So this shouldn't be a matrix, it should be an S vector. And that makes sense because it's taking the rotation on the y-axis. And that would make it SP vector. That would be a real vector. And now let's update all these. And that makes more sense. And I'm sure I got something else wrong in there along the way, but we'll fix it when that happens. 138, like I said, probably got something wrong. We're going to assume S8 and S2 are equivalent, which would mean down here in 145, we're passing the same thing, and that looks correct. Here we're getting this transmatrix value from the from the stack versus a register, and that's fine. We'll figure out why a little later. And now down here is where we're setting the other vector, and it's basically the same thing. And this is 4 byte aligned, so yeah, I'm happier with how that's working out. And comment no longer makes sense because it does look correct. So we have a bunch of load words here. Again, that's things coming from the stack when eventually we expect them to be in a register instead. 149, this is a signed value. We can assume that this is a Z rotation. Looks like at first glance anyway that this is a explicit check against 0 as opposed to just a truthy check. These are going to be slightly off because of the difference between the PlayStation. This is a prim pointer, so let's use prim here. And this actually is a good reminder that the primitive pointer is the same as a Poly GT4. Which probably is a subset of Poly GT3, which are PlayStation SDK data types that come with their structs that are defined in the PlayStation SDK. The primitive uses some of the padding fields as extra variables. And there was a prim plus X30. I'm guessing that this is supposed to be prim plus 1. We will see eventually. Looks like I got rid of an extra S. And so down here, it's likely that we're using these variables again. And so SPAD 4 is going to be our transformation matrix. I think we have, I think that's a 2-element array, but I guess not. Let's look at what matrix is. 2-dimensional array, sorry. We have 2 ways of accessing it, I guess. So we want .m. And it's a pointer. Looks a little better. I'm going to assume that this is going to be rotate each time, and then here are we writing back to the pointer directly or not? And I think we are. So there's a bunch of stack reading here that's going to make this a little more difficult than it needs to be. I might have to come back to this once. Once I have some of this removed. And I'm going to try to reuse this variable as much as possible. And we'll have to go back and look at the difference between the two. So we're going to have to bifurcate this. Actually, maybe it already does this. That would be great. So let's look at the libgte header. And what I want to see is that rotate matrix is a macro on the PlayStation. What we should do is make a rot matrix macro, because this function doesn't exist on the PlayStation. But for source compatibility, what we can do is make the rot matrix macro, a function macro, and have it called GTE matrix and just pass in, GTE rotate matrix and just have it pass in the matrix. I think that will work. It's fast memory. I don't know if the GTE coprocessor, Romy was asking, was a scratchpad used for auxiliary stack space? I think it's used for shared data between GTE, the GTE coprocessor, and the main CPU. I think they both map them in into their address space, and it's on die as opposed to in memory. So it should be accessed or accessible maybe even within like one cycle on like main memory, which takes an extra cycle to load those values. I'm not completely sure, but it's possible that GTE actually does not have access to main memory. That's all good questions and stuff I don't know specifically. I'm gonna see what Gemini thinks. No, GT can't access the scratch pad. Yeah, so I guess, yeah, effectively it is like the stack. But there's some additional guarantees about the speed. So I'd have to look at more. So I was wrong. GTE can't access the scratch pad directly. So any of that data has to be copied into the GT registers, and there's instructions, the coprocessor transfer instructions to do that. Good question, though. There's my error. Did the struct access versus pointer access again? So it looks like there's some masking that's being done up here. var v0 is... Let's do this. I'm going to... do that instead and see if that gets rid of. So what I want to see is only these stack loads as the difference. There is... That's not quite the only difference. Should be at offset 1. There's these sign extensions that are happening as well, which I don't expect. Oh, it looks like that's a plus equals and a minus equals. That's what's going on. Much better. So on the reason it was written the other way, GCC looks at this and says, I only want one right here. I already know what the value of this register is, so I don't have to reread it from it. It doesn't know that the scratch pad is fast and that it could probably access it just about as quickly as a register. Maybe it still can't access it as quickly as a register. But it knows the value of self-rotate because I had to read it there, and it knows that this is self-rotate, and so when it's doing plus equals and minus equals, it knows that it already has that value in a register and doesn't need to do it again. And it can store the result of this addition or subtraction in a register, and then only have to do one right weight on at the bottom. And so it probably will do this right because it doesn't know if this is an alias for that, but then just otherwise use the value that's already in memory for the plus equals and minus equals. And since this isn't the PlayStation, we don't get those optimizations. Oh, I have this backwards. What I think I'll do, like I said, is rewrite these as macros for the PlayStation. So that it could be source compatible either way. So there's possibly some ordering here. This LDV3 looks like I don't have that in my context. We talked about this a little bit yesterday. This is on the PSP, it's a macro like this that just calls all three of them. And should go through and basically get rid of all the GTE macros because they are incorrect on the PSP. And they're going to be incorrect actually on the... Let's do this. I can't do that quite. Let's do not open parens star parens inline. And why didn't we find... Oh, because parens is special. Do I have to escape it there too? No. How about this? Dot star parens dollar. That should... Just getting rid of all those macro definitions. So this is wrong. So we're adding 30 to primitive, but we have to subtract 4. So we're adding 2C to primitive. So let's see what the field is at 2C. It's 3. No, that's, we want a reference to it. Okay. So we're loading a 1 into the third byte on 188, which is the same as pad 0, but we have a register for that, which is our transmatrix. I can't remember if that's transmatrix or the other one. Oh, we don't have one for that yet. So where's S6 set? It is set way at the top. This is our SP vector. All right, we're almost done here. So we're loading this value. Adding $200. So this would be a check for, instead of adding 200, it's probably a check for greater than negative 200? Nope. So why do we need... So then this would be a +3. And this is going into our rotation vector. No. transformation matrix. We're dividing by 2, dividing by 4. We'll work through this a little bit and see how close or far we are. It looks like this may be a divide by 4 up here, and maybe that's what all this mumbo jumbo was about. Add 2 and then divide by 4. Or add 200, add 512. We're not doing the shift down here. And that may or may not be correct, but the issue is going to come down to it's not quite right. Let's try that. Looks like var a1_2 should be a 32-bit value. It is. And priority is a half, so this is not quite right. Let's check out M2C just to make it go a little quicker. Yeah, so this does look like it's the plus 200 divided by 4. I'm fine with that. And maybe this is all just together and not in a separate variable. No, it's happening in S. Yeah, let's try to do it in line and see if that makes any difference. And then I think if the instructions look mostly right, I'll go fix variables and then come back to this and make sure that it's actually right. Because there's still there's like a load half in here that's missing, or that we have that shouldn't be there, which means that might be pulled out earlier. We have some masking that's happening that there is masking down here, but we don't have quite the same. So there are some types that are wrong, it looks like. So we'll have to come back and see. I'm going to fix variables. We have at least one too many variables now on the stack. And before we do that, though, no, don't fork it. Don't fork it. Before we do that, let's check out the PlayStation and see what's going on. So I switched over to the rotation matrix and set matrix functions. We're gonna have to turn those into macros for the PS or for the PlayStation. Because what we want actually is the GTE versions of those. And the GTE versions don't take the same arguments. I'm going to go back over here and look at GTE. So maybe this is a combination of set matrix. So let's do this. Let's go to get rid of these. And here we want that to be GTE. I think it's set rot matrix M. But there is a rotation matrix function as well. So maybe I just need that for the set rotation matrix. Yeah, that looks better. So we'll limit that to and that looks much better. Let's make sure that still works on the ESP. Yep, no difference there. I'll take that macro and move it over. Sorry about that. All right, so the PlayStation looks pretty good. We're at 95%. Our stack is actually looking much better. Still too little here. Down here in this section, we have one additional variable here or assignment that's not being done in the original, and as we go through, maybe we'll figure out what the cause is. It looks like that assignment's not happening until 149. It is possible that I've screwed something up along the way. It's hard to know with the optimizer. So we'll keep working. So let's start cleaning up variables. V0 is gone. RE1 is gone. Temp V1. So like I said, it looks like we have one fewer variables than we need. And is that actually the case on the PlayStation as well? The PlayStation thinks the same. So we're in an enviable position of having to add more variables. So let's go through and see where these are being used and what we can do. Well, let's start with S0. $27. So in both cases, S0 is our primitive, but it's being used temporarily here. It looks like for self, which is strange. There's the sign extension on 28. So we'll hopefully that works itself out later. Prim index is S7. We want it to be S8. But it's fine otherwise. Oh, I noticed a big block of something. That's missing 154. Something is missing here, storing a word. So offset 3C was this primitive X, and we're storing it into, oh, we're storing again the scratchpad SP vector. Nope. SP, the transformation matrix. Nope. Something different? Something altogether new. Looks like the rotation vector. Oh, maybe not. Let's just try SP vector at spad 1. And then it looks like we're storing value 1 at X3. No, oh, yeah. From next would be too far. So we're at offset 3. I gotta remember to 3C, so that should be 2C. C is S. Oh no, we're 4 bytes. So 3C minus 4, that's 2, 8. R3? 3C minus 4 is 3, 8. 3, 8 is not. Not in that vector. It's in the, so that can't be right. Oh, stack pointer 3C, duh. Not what we're looking for. So we're storing value 1. Oh, that's our I. So this should be here. Nope. Maybe? What is offset 3C? No, because next prim is a pointer to another primitive, and they're not necessarily in line. I don't actually see anything else that's using offset 3C. So it's some variable that's on the stack that's never used. So we're loading a 1. Oh, yeah, something is getting set, and let's just choose something. It might be the transformation matrix, it might be something else. But it looks like something is getting I'm going to make a new one. And offset to scratchpad 0. And so this is getting put into a register. It might be something else. We'll see. We'll figure it out eventually. But it looks like it's an unused. Sorry, thank you. It looks like it's an unused variable. So I don't see anything. So v1, which is just the value 1, is getting stored to offset 3c on the stack. And then nothing ever reads offset 3c from the stack again. So it's a dead store. So we're not going to get any hint on the PlayStation where this goes. Unfortunately, when I do this, it's getting written to a register. But we have other things to worry about, so I'm gonna keep going. And we'll come back to it and see. How's our stack? We still don't have enough variables on the stack. So back to variable hunting. 33. I is S1. var A1 is S3. This one is also S3, so we can just use S3 for that. Let's look here. So it looks like this was a Sine 32 GTE LDV. That might take a vector. Offline, I'm looking at libgte.pdf. I think it's libgte. One second while I try to find this. I had it somewhere. Inline ref? Yeah. Give me a second. Yeah, so it looks like it's 3D coordinates, so it's an S vector. So this should be a pointer to an S vector. Or a reference to an S vector. 182. Let's see if S vectors though are 64 bits, I thought. So this must be an S vector pointer array. Let's look at this data and see if these are pointers. They are pointers. Okay, so this that's helpful to know. So I have these as Sin32s, but really they're S vector pointers. That's going to change some things. And right now, it may be that var A1 is also an S vector pointer, but that doesn't make as much sense here. 36. So it must just be coincidental that this overlaps. Let's look at that and see what that is pointing to. And those look like bytes. Okay, so it looks like it's just coincidental that those two variables end up pointing to or being used by the same register. So now I screwed something up along the way. So this is the S vector pointer. Let's look at this. See, we're doing 97%. Still short on stack. Let's go down to 14. That's where our next, down here, that's where our next register is. Or our next variable, sorry. And so we have that as S1, but it should be S5. Speed trans matrix. And S2 and S7. And so we don't have anything for S6. 1, 2, 3. No S4 and no S6. Let's go try to find those and see what they might be. No, I've read that wrong. Var A1 is S4. For us, it's S3. And those are used the same. There's this is out of order. I had that right. Okay, let's see if it's used anywhere else. Doesn't look like it. And then S6. S6 looks the same as ours. There's a difference here on 190. I said I might have screwed these up, and it looks like I did. So it's not the transformation matrix. like it's probably SP vector. I thought I had S6 right. But it looks like not quite. So let's figure out what's going on with that. I think that means it must have been the rotation vector. Because I think rotation vector was S. Oh no, it's not. SP vector is S7. S5 is SP transformation matrix, so 141 should be SP. Now those registers get reassigned. It looks like they did. Okay, so right now our S5 is that. Let's use the rotation vector down there instead. Okay, those align now. Might be worth working through this 190. Now the vector. Oh, we have S8 down there, which is just SP vector. And so we have one more thing being loaded from the stack. Which looks like self. So I think we're doing this and storing it into, are we storing it into a register at the end? What I want to see is a store word. I guess it could be just from the one of the operations too. It doesn't have to be that specifically. Put into an S register. I don't see that. Possibly this. So we're adding 16, which isn't happening. Oh, so something is being S3 is being incremented. We don't have. And S3 was E2 bar S3. So we're missing a var S3 plus equals 4. Okay, that's not everything though. Looks like we need a unsigned 16 somewhere. So let's make a priority variable. I don't know if that's what's missing, but unsigned 16. Okay, not quite right. Oh, it could be that simple that it's instead of a plus equals, it's explicitly reading that it looks better. We're missing maybe it's not getting it, maybe it's from self. Self doesn't have priority. So we're reading it not from priority, but somewhere else. And S0. 0 should be rem. So we need something 6 bytes earlier. It's like X2. Self isn't gonna. It's possibly self. So self is a entity. And entity offset 24. Does that make sense? Z priority, yeah, that makes sense. I wonder how that got lost along the way. So that's pretty good. We're still missing something on the stack, though. And what is this? I saw something missing here. A store word. Maybe this is the key. 157. Yeah, it's a store back to the stack that. There's a way that I can force this that's not ideal, but it's if I make this an array, I think that this will, yeah, like I said, not ideal, but it works. And we can make that as big as we want to fill out the stack. But we're missing a register in the process. So close. Let's see if that works on the PlayStation. So a little closer on the PlayStation. Registers are still wrong. 191. Something's still funny with this. Basically the ordering. That looks like maybe something coming from the optimizer. 156. I think, yeah, this hates the array assignment. I hate it too. So he basically GCC's not optimizing it out when it should be. So we know that there's something there that should be optimized out. So we're getting closer, not quite right. I think just a little bit more work and we should be able to get this, but I don't have any more time to work on it, so we're not going to get it today. We'll keep working on it tomorrow, though. So we've been decompiling Castlevania Symphony of the Night. Thank you, Willie OD, for showing up. Dizik, roaming, as always. Appreciate it. And I'll see you all tomorrow. Adios.